Hello students, welcome to Learner's Planet, theory session 6 of carbon and its compounds. So for past 6 sessions we have been discussing the properties of carbon and the compounds it is forming, and as well as the nomenclature of these compounds. In this session also we will be discussing the IUPAC nomenclature only. I have to tell you how to name the compounds with different functional groups, that is like alcohols, like aldehydes, like ketones. These are new to you, so I'll be introducing you to these groups. So let's start our session. Now in this case, what is it here, students? It is an atom or group of atom which makes a carbon compound reactive and decides its properties is called a functional group. Okay, that is whatever the atom is present, or there is a group of atom and it is making that compound reactive and also deciding its properties, that is called as what? Functional group. Like our first functional group is halogen. Halogens can be chloro, bromo, iodo, and halogens are always named as the prefix, right? Like this is chloropropane. What else can it be? Say if I'm taking another example, like this is CH3, CH2, C, Br, CH3. What would be its name? I told you that you have to assign a number to the carbon to which substituent group is present. So what should be its name? Let's start numbering. 1, 2, 3 and 4. So it should be 2-bromo. How many carbon atoms are there? 4. So it should be butane. So this is how halogens are named. Let's see, halogens, not halogens, that is the organic compounds containing halogens are named. Let's take a few more examples. Yeah, there is alcohol. For alcohol, the suffix is -ol. And what is the functional group here? Or which group is assigning alcohol that particular property? So that suffix here is OH. So which group is assigning this property of alcohol? OH group or hydroxy group, right? So here there is an example of a compound that is 1, 2, 3 carbon atoms. That is, it is propanol. Let's take up few more examples. I'll write and you try to number, you try to name these compounds. See, I'll take up here one example, that is CH3, CH2, CH2, COH, CH3. What will be the name of this compound? This OH is a principal functional group. Now in the stable students which we are doing, the functional groups are arranged according to their decreasing priorities, right, or the increasing priorities. Now in this case, what is the name of this compound? Again we have to number. Can I write it straight? That is 2-pentanol. So here students, remember, you have to assign a specific number. So if I am taking another example of it, that is CH3, now what will be its name? Again you have to start numbering. So it should be 1, this is 2, 3, 4 and 5. So it should be what? 2,4-pentane diol. Why diol? Because there are two hydroxyl groups in the chain. Okay, so this is your pentanol. Likewise, what else we can take? We can write hexanol, that is with a 6 carbon atom, or I can also write isopropanol, that is if I am branching this chain. So this is what will be the name of this compound? This is the highest priority, so it should be 1, then 2, 3 and 4, and at second carbon there is a methyl group. So what I'll write is 2-methyl butanol. Okay, or if I am taking this chain, now this OH has got higher priority, so I will start numbering from here. Okay, so what I'll get is 3-methyl, methyl will be a prefix, so it should be 3-methyl what? Pent to all. Okay, so the position of alcohol group has to be assigned. The hydroxyl group position has to be assigned if there are 2, or if your alcohol is present in some other carbon atom. Aldehyde. Now in this case, what is the suffix? It is ol, and in aldehyde the suffix is al. And here, students, what is the functional group here? What is the functional group? The functional group here is CHO. This CHO group is assigning or is responsible for the properties of aldehydes. And one thing you should remember, that in aldehydes, what happens is that an aldehyde group, in aldehydes, your CHO group is always present at the terminal carbon atom, that is the first carbon atom. CHO group is present at the first or the terminal carbon atom. It is present in the terminal carbon atom only, and your CHO group is also counted. Like if I am writing the structure, now what will happen is that in this particular compound, the aldehyde carbon is also given one number. So if I am writing the numbers over it, it would be first carbon, second carbon, third carbon and fourth carbon. You can also see, students, that the aldehyde carbon is always assigned number 1, right? The line starts from where the aldehyde carbon is present. So what would be its name? The number of carbon atoms are 4. So what would be the root word? Butane. What is the suffixes? Al, that is the secondary suffix. So it is butanol. Is my point clear? Or I'll take some more examples of it. That is CH3, CH2. What will be the name of this? So what I'll have to do is I'll have to number these. Let's number 1, 2, 3, 4, 5 and 6. What is the root word? How many carbon atoms? 6. So what is the root word? Hex, right? And what type of bonds between the carbon atoms? Single. So it should be ane, right? Ane. Replacing this E by al. What would be the name? Hexanal. Clear? So I'll take one more chain so that this concept is at least clear to you. So it is CH3, CH2, CH, and I am putting in OH here. Now how will you name? Now in this case, children, or this hydroxyl group or CHO has more priority than OH. Sorry, this is priority. So the compound will be named as aldehyde. Okay, and what will be the substituent here? The substituent or hydroxide group is substituent. Okay, now let's start numbering this chain. What I told you was that we have to number from the aldehyde carbon atom. So this is 1, 2, 3, 4 and 5. What would be its name? It should be 3. What would be the prefix here? Hydroxy, right? So it should be 3-hydroxy. Okay, how many total carbon atoms are there? Root word 5, so pent, right? What type of bonds are present between the carbon atoms? Single bonds, so in, and its E will be replaced by al. So what should be its name? 3-hydroxy pentenyl. So based on the priorities, these compounds are named. Like your chlorine has got lesser priority than hydroxy. Hydroxy has got lesser priority than aldehyde. Now we have got this another group, that is ketone. The suffix is ONE, it is one or own we say. It's not one, it is pronounced as own. Now what is the functional group here? The functional group here is C double bond O. That is, this is your functional group. So this is C double bond O is the functional group. Here what was the functional group? C double bond O and H, that is CHO. Okay. Now how these ketones are named? They are named as ON. Like here there is the simplest one, propanone. Okay. Let's take up examples of this. Examples of ketones, that is. So ketones, the functional group is C double bond O. Now if I write the chain like this, now what? This is what? How many carbon atoms are there? Let's count. 1, 2, 3, 4 and 5. Right? Now in this case, students, what you have to do is, you have to give a specific number, that to at which number your ketone group is present. So this will be pentane 3-one. Right? Or I can also write it as 3-pentanone. That is, at the third carbon your own group is present. But it's better to write like this, pentane 3-one. Or its common name would be what? Both the sides there are ethyl groups, so it would be diethyl ketone. It's better you don't go that side. I'll take up some more example. That is CH3, CH2, CH2, C double bond O, CH3. This is also what? How many carbon atoms are there? 1, 2, 3, 4, 5. But this is what? Pentane 2-one. So this is how your ketones are named. You have to assign a number where that ketone group or the keto group is present. Now let's move to the next things. Yeah, here it is carboxylic acid. The suffix is oic acid. Right? How you name the compound containing carboxylic acid is oic acid. And what is the functional group here? It is COOH. That is, your functional group is COOH. And in this case also, students, it is the terminal carbon. So what is its name? How many carbon atoms are there? There are 3 carbon atoms. So the name is propanoic acid. Now let's take its few more examples, like propanoic acids. Say I'm writing this CH3COOH. What would be its name? How many carbon atoms are there? There are 2 carbon atoms. So what would be the root word? Eth, right? And it would be ethanoic acid, right? HCOOH. How many carbon atoms are there in it? 1. So what would be the root word? Meth. What would be its name? Methanoic acid. This is also called as what? Formic acid. Okay, how your acids are named. Likewise, there will be propanoic, butanoic, pentanoic, depending on the number of carbon atoms present. Okay. Now there is a double bond and triple bond. I have told you this is the suffix "ene" or "ion". So I have told you the namings of alkenes and alkynes. Now the functional groups in the table are arranged in the order of their increasing priorities and not the decreasing priorities. Okay, so it is increasing priorities. So these are arranged in the order of their increasing priorities, right? Except double and the triple bonds. And triple. So till carboxylate group, the priorities are increasing. Now here is one example, students. It is in the following compound can be named as. How this following compound can be named? This is the compound. Now I hope you can name this compound because we have discussed a lot regarding the nomenclatures. Say it is, how many carbon atoms are there? 1, 2, 3, 4. What will be the root word? But. Then which has got a more priority according to the table? It is hydroxyl group. So the compound would be named as a alcohol. So what would be the suffix? Suffix should be "ol". Then what about the other substituents? That will be named as a prefix. Okay. So this prefix is chloro, and apart from that you have to also add the name. So that is 3-chloro. Okay. Now what will be its name? 3-chlorobutanol. So this is, I hope this is clear to you. When you'll practice more, it will be more clear to you. So the carbon atoms are numbered from the side of the functional group, right? OH in this case, because hydroxyl group has got more priority than halogen group. Let's discuss few more examples here. So shall I write the priorities? There is the halogen is the least. Then comes your hydroxy, OH. Then comes your aldehyde, that is CHO group. Then comes your ketone group or keto group. Then comes what? Acid. So this is the increasing priorities according to which you have to number the carbon compounds. According to which you have to name the carbon compounds. So for example, I have got a carbon chain like this. I have got a group like OH here and the C double bond O also here. So how will we number this? We will number it from this side which has got more priority, students. Which has got more priority, keto group or hydroxy group? Keto group. So numbering should be such that the keto group is getting the least number. So it should be 1, 2, 3, 4, 5. And the compound will be named as ketone. So it would be 5-hydroxy 3-pentanone. Say I'll take another example here, that is CCC. This is example 1 and this is example 2. What all groups you want me to put here? I'll put that CHO group and I'll put one this thing, chlorine here. So which has got the more priority? CHO has got the more priority. So let's number 4, 5, 6, 7. What would be its name? It should be 5-chloro and heptanol. So students, you don't need to number the aldehyde group. Why? Because this aldehyde group is present in the terminal position only. It's always. So you don't need to number this. So try to practice more and more molecules, so that you are able to name it. And this nomenclature, students, it is very, very important. So I think I'll conclude this class. We have discussed enough of the IUPAC nomenclature, its rules, and we have discussed lots of examples also. So in my next session, I'll be meeting with the properties, that is the chemical properties of the carbon compounds. So I would like you to practice more compounds, more of the nomenclature. Okay? To summarize the rules of IUPAC nomenclature, I would just say, first of all, what you have to do is count the number of carbon atoms. Then write the root word. Second, find out the type of bond between the carbon atoms and write the primary suffix. Third, work out for the functional group if present. Right? Assign the carbon with the functional group the least number. Fourth, work out or search for the substituents present. Right? Make them as a prefix. And of course, don't forget to number the carbon to which the substituent is present. Fifth, if more than one substituent is present, then arrange them in an alphabetical order. Sixth, the sum of the numbers assigned to the carbon atoms with substituents should be the least. Right? Otherwise, assign the least number to the group which you are writing first. So these are certain basic rules, and for you I have written that priority listing also, right? So these are certain basic rules. Keep these rules in mind and start naming the organic compounds. The more you'll practice, the more you'll be through with this concept. Okay? So practice this, and I hope this lecture is clear to you. So these are some names of the compounds, that is CH4 is methane, C2H6 is ethane, C2H4 is ethene, C2H2 is ethyne, HCHO is methanol, CH3CHO is ethanol, and the CH3COOH is ethanoic acid, right? So I'll conclude this lecture. Thank you very much for listening patiently. I hope you are going to practice nomenclature.